Okay. So yesterday we understood about the list data type, right? So today we are going to discuss about the tuple data type and the set data type. Both we'll discuss. Now, before I get into that one, tell me, lists are mutable objects or immutable objects?
Mut-
Mutable, sir.
Mutable objects.
Mutable objects, right? So ordered or unordered?
Ordered.
Order will change? No, right? Yeah. So list allows duplicates or not?
Yes.
Yes.
Allows.
Yes. Yes. Okay. So because I'm going to discuss about the differences between the list and tuple, that is the reason I'm asking the same question here. Okay. So once we complete the tuple concept, like we'll understand the differences. Okay. So next concept, next data type is tuple. Some people call it as a tuple. You can call it in any way. No problem. Both are same only. Okay. Uh, Tuple is also a like collection of elements, I can say. When I say elements, it can be a heterogeneous or it can be a homogeneous. When I say homogeneous or heterogeneous, homogeneous means same kind of data types. Heterogeneous means different kinds of data types. Okay. So I can have strings, numbers, combination or any other data type combination, or I can have only strings, or I can have only numbers, or I can have only integers like that, or it may be a combination of all those. Okay. So same like list only. But tuples are actually represented with the round brackets. That is only the difference here. Open brackets, parentheses, I can say. Okay. That is the first difference between the tuple and the list. And the second difference is tuple items are ordered. Same like your list. Ordered means in whichever the way you created that object. So order remains same. Order remains same. Okay. And unchangeable. They are immutable. Tuples are immutable. List is mutable object, but tuple is immutable object. That means once you create the tuple, you cannot modify the elements or you cannot modify the tuple at all. And it allows the duplicates. Let me prove that one. So how to create a tuple here? This is the way to create. So anything you, like any item that you represent within open brackets is nothing but a tuple here. Okay, so let me try to prove that one, whether it is creating a really tuple object or not. So let me go here and try to create like this. Okay, so this tuple equal to apple, banana, cherry, whatever the elements you want, you can take it here. I'm just trying to print the tuple. Okay, if you want to know whether it is creating a tuple object or not, what is the command we need to use? Print of type of
Type this
uh,
tuple.
so type of this tuple. Okay, tuple. Okay, execute this one entire thing. See. So it has printed actually a tuple and it is saying that it belongs to tuple class. That means it is a tuple object actually in the bracket. Sorry, in the backend. Okay. So, and what else it is saying? You access this one n number of times, the order remains same. Okay. So, and one more thing is, since the order is not changing here at any point of time, can you access the elements using its index?
Yes.
Can you access the elements using index?
Yes.
Obviously. Obviously we can access. Okay, so how to take that one? Okay, so come on, help me here. This tuple of
Zero.
let's say 0, you can take. See what it is giving? Apple it is giving. You take 1 here, second object you'll get. You try to access the elements using its index value, that's it. You 2 you give here, just you'll get a cherry here. And 3, which is not there, but you try to give that one. See what it is given? Tuple index out of range. I told you already, this is actually indexing. In the indexing, if you try to give like more than the length of that particular tuple, then it will throw error. That's what I mentioned already in the strings. But slicing, that will not happen. But in the indexing, it happens. Okay, so now you know like how to index the, how to access the elements using index. Okay. Uh, okay, they are unchangeable, right? Okay. Now what I wanted to do is, how did we modify the elements in list? How did we modify the elements in the list? Let's say tuple of 2 equal to, what I will do is, I'll just try to keep here Orange. I just wanted to update second index item with orange. Instead of cherry, I just wanted to update it with orange here. Now, since they are immutable, is it possible to update the item here? Let me
No.
check it. See,
No, sir.
tuple object does not support item assignment. Similar to your string. Since they are immutable, you cannot modify it. Once it is created, you cannot modify it. Object cannot be modifiable. Okay, that is what you need to understand here. And I proved this point as well. Okay, and allows duplicate values. So if you want, I can prove that one again. Apple, okay, Apple I can take one more time as it is. I'll try to copy paste here. Okay, as last element, I'll just try to put it here. Now see, it is allowing or not. Yes, it is allowing here duplicate values. Similar to your list. Okay. Now, can we try accessing the elements using slicing? Okay. Now, can I write 1 colon 2? Is it satisfying the rule? What is that rule? Begin index should be less than end index. 1 less than 2,
Yes.
satisfying. So, okay. So, I wanted to remove this one. Yeah. So, this tuple of 1 colon 2. So, that means rule is satisfying. Then, if you try to print that one, see, since it is creating actually a, so since it came like this one, I wanted to discuss one more point. 1 to 2 means this is one index 1 actually. Okay, 2 means 2 minus 1. 2 minus 1 is nothing but again 1. It will print only banana. And I told you already yesterday also, when you are slicing list actually, what is the output object type actually? What was the output object type? List only, right?
Yeah.
It has created list only, right?
Yes.
Similarly, here also, when you try to access the elements from the tuple, okay, so it creates actually a subtuple. And the output is of the same data type, I can say. See, remember in Python, single value value tuples represented like this. Single element tuples can be represented like this. Okay, you may ask a question, Shiva, why don't we represent like this? Okay, so tuple T1 equal to what I wanted to do is within curly brackets, sorry, within square open brackets, I'll simply mention A. That's it. Now, will it create tuple? What do you think here?
Yes.
Okay, how do we check whether it is creating tuple or not? Print of
This type.
type of T1.
T1.
Yeah.
Okay. So and print of T1 also, if you want, I can uh, take it here. T1. Now see what is happening here. Is it creating a tuple? Is it
No.
creating a tuple? Something weird right here. Different behavior, right? So remember, single value tuple actually always we need to represent with comma. That's it. That is the rule here. Okay. So once you keep like this, then it will consider it as a tuple. Multiple values, of course, you can represent. So it will treat as a tuple only here, definitely. But single value tuple only we have to represent like this with comma. That's it. That's the rule actually. That is what I mentioned in my next slide. This is the one. Okay.
This is
Or you can take in this way also. If you want to represent that one, you can take within a list. See, indirectly, what are we trying to do is this list we are converting into tuple. Backend, it will try to print in the same way. Okay. So that is one point. Anyway, I think we were discussing about the like slicing, right? So 1 colon 3 I'll take here. Now we are getting two elements, banana and cherry. Can I play with the negative numbers? -1, -3. Come on, help me. What you'll get?
Empty.
-1, minus. Rule is satisfying or not, first of all?
Yes.
-1 is less than -3?
no.
No. What you'll get output?
Empty tuple.
Empty tuple, exactly. You always need to remember that formula. Okay. Now, can I take one column minus 3, one positive value, one negative value. When you have mixed values, what's the rule? Rule is opposite, right? Begin index should be greater than end index.
Yes.
1 is greater than minus 3. Satisfying rule?
Yes.
Okay. So am I going to get the output here?
Empty same.
Empty. Why are we getting empty here?
Both are same questions. So my negative minus 3 is same, 1 is same.
Minus 1, minus 3, same.
Minus 3 is banana only, right? Again, 1 is also banana, right?
Ah.
It's a minus, so it's, yeah.
So okay, so you're getting it empty tuple. Okay, so if you want to play mixed values also, we took it. Okay, so if I take minus 1 here and let's say 3 here, rule is satisfying? Rule is satisfying? 3 greater than minus 1?
Minus 1, yes.
Yes, okay. Now what I will take is colon minus 1 I will take. What will happen? What's your output?
Empty.
Empty again. Why?
Negative step value minus 1.
Minus 1.
Exactly. End value is minus 1.
Yeah.
If end value is minus 1 in the backward direction, the output is always empty.
Empty.
Okay, you need to remember. See, that rules are applicable to all the data types. Once you remember that formula, then it's very easy to judge the output. Okay, so that is about slicing. Moving on.
One doubt, sure. Tuple will allows only single type of data types inside elements, only strings, or it can be numbers also.
It can be anything. It can be anything.
Combination
Okay.
of both, right?
Yeah, combination of anything. So one I can take here. See, it is creating a tuple only. So
like list. Apple
I can
1,
take
A,
1
B,
here
C.
and I can take 1.4 here. Okay. Something like this. Can I take?
Yeah.
Heterogeneous elements, right?
Yeah. Yeah.
So that's what I mentioned. So this is number, this is string, and this is float.
Float.
Okay. So it's a combination of any other data type, you can say.
Okay.
So slicing also done, indexing also done. Okay. So since we cannot modify the elements in the tuple, do we have the methods, like whatever the methods we discussed in the list, right? So all those methods are applicable to the tuple as well. What was the first method that we discussed in list?
Append.
Append, right?
Yeah.
Append, right? So can we use the append here? Once you create the tuple, can we add the elements to the existing tuple?
No.
No, sure.
No. We can
So
add.
that means append method is applicable to tuple.
No.
Any method that is modifying the tuple object is not applicable here. Simple. That means append is not applicable, insert is not applicable, remove is not applicable, pop is not applicable. All those methods are not applicable to tuple. The only methods are available in tuple is one is index and second one is actually count, I think. One is index and second one is count. That's it. Count is just to count how many times the element is repeating. That's it. Anyway, we don't use that one like that much. Index is nothing but like if at all, if you want to find out the first occurrence of that element, then it will try to give that. We don't use this one also that much. So there are no methods to discuss in tuple. There are no methods except index and counter, because tuple objects are immutable objects. Since we cannot modify them, no this one methods are applicable here. Make sense?
Then in the real time, will you use tuple very often?
Yeah, we use that one. So directly we don't use, but indirectly we use that one. In Spark, actually, backend operations happens through tuples only.
Okay.
Backend operation completely using tuple only. Okay, so even normal these things also, normal tuple objects also, based on your requirement, you use it. That's it. Okay. If you don't want to modify the values, then you go ahead and create that.
Hey, a quick question.
Yeah.
అది మనకి మ్యూటబుల్ ఇమ్యూటబుల్ కాన్సెప్ట్ డేటాబేస్ లో ఉన్నాయి కదా, ఆ కాన్సెప్ట్ ఒక్కసారి రిఫ్రెష్ చేస్తావా? అది రిలేటెడా నాన్ రిలేటెడా? అదేంది ఇది
Mutable,
కన్ఫ్యూజన్
immutable.
పడుతుంది.
What is that
మనకి
in data warehouse?
అదే బేసిక్ కాన్సెప్ట్ ఏంటంటే మారటం మారకపోవటం అంతే. అది ఐ మీన్ రీరైట్ అవుతాం రీరైట్ అవ్వకపోవటం అనే మీదే ఉంది. సమ్వేర్ ఐఎమ్ గెటింగ్ కన్ఫ్యూజన్ బిట్వీన్ దిస్ టూ. అసలు రెండు ఒకటేనా
I
వేరు వేరు
don't
ఉన్నాయా?
think so. Immutability concept is there in data warehouse.
అదే ట్రాన్సాక్షన్ డేటా, అనలిటికల్ డేటా అనే
Oh,
కాన్సెప్ట్ లో
that is
వచ్చినప్పుడు
different. That is
ఈ
different. I
ముక్కలు
don't want
వస్తుంది.
to mix up that concept here. That is
ఓకే
completely different.
ఓకే.
You're talking about the OLAP and OLTP, right?
ఓ ఎస్ ఎస్
That is
అటువైపు.
completely different. That is completely out of the subject.
सर की खा जा हमारा क्या बने
Sir.
आपके लिए मिश्रित भाई? चिकन चीज से अंदर क्या खा?
Okay. So moving on. Sorry, Bala. I'll try to discuss that one bit later. I mean, at the end of the class, not now, because that is
No issues.
completely out of the subject. Okay. Okay. So the next one is, can we sort the elements inside the tuple? Directly, it is not possible. But what we can do is, like, we can create a. Okay. Let me try to show you why I'm saying like directly it is not possible. So let me execute this one. Okay. So if I don't use this tuple here, okay, then what happens here? That's what I wanted to understand. So names equal to this tuple I've taken. This is the base tuple I've taken. Sorted names equal to sorted of names. Sorted of names. Okay. So what do you think here? Is it going to create a tuple again? No, it is going to actually create a list. So if at all, if you want to create it as a tuple, again, you can use the conversion function tuple here. Conversion function tuple. Okay, then it will create actually a tuple. Tuple of something, if you give, like it will try to convert into tuple object. Okay, just remember that one. So sorted is a function. It's not a method. It's not a method. It's a function. So sorted function always like gives the output in a list format. You take any object, you pass any object as an input here. Ultimately, it is going to create a list only. On top of that one, tuple object we are using here. That's it. Okay. So, I mean, if at all, if you want to like sort the elements in a reverse order, I mean, descending order, then you know already like reverse equal to true, right? Okay, you can use that one at any point of time, no problem. So deleting concept is there in every object, guys. I mean, because del is a keyword, it's not a method. So what del does actually, it deletes the entire object. Okay, so since it is no way related with the mutability and immutability, still we can go ahead and use this del keyword on top of tuple. Okay, so this deletes the entire tuple object from the memory location. This we have seen already yesterday. Okay, so update is not supported. We have already discussed this one. You cannot modify the element once it is created. Okay, similar. Okay, so methods are done. Now we'll try to understand any functions are there on top of the tuple. So similar to your list. So we have repetition T1 star 2 means like it will try to repeat the elements here. Same concept like your string and the list. Okay, concatenation same like list only. T1 plus T2 means it will try to add it will try to just concatenate the elements to the resultant tuple. Okay, membership also you guys know like how to check that one. Okay, we have seen that one also. And the iteration, you guys know how to iterate that one. Again, same thing, same like your this one only, list only. Okay, if you want, I can iterate it quickly. So let me open the new cell here. If at all, if you want to see any iterable object, we can iterate. We can iterate the elements, guys, from any iterable object. It can be list, it can be tuple, it can be set, it can be like dictionary, it can be anything. Okay, so how we can use that one is for I in a tuple. Oh, this names, right? Okay, so tuple name is actually a this one names colon we need to take, hit enter. It will start indentation. It follows actually. It starts after a couple of spaces. And what we need to do, we just need to print this one. So print of the temporary variable, whatever I is there.
I.
That I see in place. There is no rule that like we have to use every time I here. I mean, we habituated to this terminology. That is the reason I'm using I here. That's it. But don't use I every in the real time. Okay. Relevant names. Let's say you have file names in a here, right? Let's say file names. The variable name is file names. You take for file name in file names. Even in the real time, also don't use I, J, K, like how we are practicing, right? Don't take in that way. Okay. So print of I. Let me print here. See, it is printing all the elements in the tuple. Okay. Okay. So next length is also length of tuple means you'll get the how many elements are there in that tuple that you'll get actually. This also we have seen in the list. I'm not repeating that one. Same min max also there. So if at all, if you want to convert any sequence into tuple, you can happily convert that one. Okay. Or simply I can say that, 1 second. Simply I can say that you can take in this way also. Sequence is nothing but values. That's it. Okay. So T2 equal to 1, comma 2, comma 3. If you assign this one, backend it is going to create actually a tuple object. Okay. So print of T2 I'm just taking here. T2. And I wanted to understand the type of object as well. So print of ID of T2. What it is creating? See, it is creating a tuple only. You can create the tuple in this way also, just by assigning the taking the sequence like this. Sequence means it doesn't need to be always like a specific order. You can take 3, 3, 1, 2 also, no problem. 3, 3, 2, 3 also we can take here. See, it is creating a tuple here. Sorry, type, right? Not ID. Type of T2. Now see, it is creating a tuple. Okay. Or if you don't want to take that one, tuple off also you can take here. No problem at all. Tuple off some sequence. Anything it is okay. Oh, tuple expected at most 1 argument, got 3. What happened here? Okay, so I think we need to put this one in separately, and we need to convert. Tuple can take other sequences and input, I guess. Okay, what I will do is I'll just try to take this one, L1 equal to, within brackets, I'll just try to take these elements. Now I'll just take this one here. So we can convert in this way. Yes. Not directly. We cannot directly pass the sequence to the tuple function here. Okay. That is one thing. Next, this is mostly asked interview question, guys. What is, we are done with the tuple topic. Okay.
Shiva,
So,
in case of 1 minute, Shiva, in case of loop,
mhm.
can we sort directly in the function, Shiva, like print I dot sorted? Uh, like in case we need to have a
Okay. So in the for loop itself, you wanted to sort them.
yeah, Shiva.
It cannot take like that. It will try to take the first element, second element, third element, fourth element like that only. It cannot directly take the picks the element in a sorted way.
Okay.
Okay, what you can do is I'll tell you one more option. You try to append that elements to a list, and on top of that one, you try to use the sort. That's it. That is only the option I have.
Okay.
Okay. Okay. See, instead of printing, you just try to add that elements to the empty list. Okay. Finally, you try to, once the for loop is done, you sort them. That's it.
Okay, sir.
That is only the option. Okay. So we are done with the tuple, guys. Tuple is very easy one only. Just represented with the open brackets, and it is immutable, and it is ordered, and we can access the element similar to list. That's it. Other than that, nothing to understand in tuple. Okay. The mostly asked question in the interview is, what is the difference between list and tuple? Come on, give me at least like 3 to 4 differences.
Mutable, immutable.
Mutability, immutability.
We cannot use methods.
So we don't have methods like modifying methods like append, insert, pop. That kind of methods are not applicable on top of the this one. Okay, tuple. What else?
It
In
allows
case of
sequence of
single
elements.
single element, we need to give comma and
Comma. Yeah, absolutely. Okay, so lists are represented with square brackets and tuples are represented with the open brackets, parentheses. Okay. Performance point of view, lists are slightly less memory efficient compared to the tuple because lists are mutable, right? Because of that behavior, actually, less efficient than tuples. Tuples are bit fast, like compared to list. Okay, so yeah, those are only the differences I can say for now. So
Can
if
we
sorry.
Can we convert from tuples to list and list to tuples as well,
Yeah,
right?
yeah, we can. That's what I've done right now.
Yeah.
So list I've created here, I just converted that into tuple.
From
Tuple also you
to
can convert into list, no problem. Okay, so what I will do is, I'll just try to take the tuple here. Okay, I'll use here list function here. Okay, so then you try to print this and see it is creating a list. So vice versa is possible.
Okay.
List can be converted into tuple, tuple can be converted into list. Okay, yeah. So you try to write down the differences, guys. This is mostly asked question in the interview. Okay. Other than these differences, if you find out, like just let me know. Tomorrow we can discuss that. Okay. Any other question before I move on to the sets?
Shiva, when we doing loop, right, for the tuple, so sorted off that I we can take it, no? To sort it.
No, sorted off I means like it will, you'll get only, at any point of time, you'll get only one element right here. What do you sort in within that element?
Print of sorted off I.
No, you'll not get right anything.
Not get.
Okay, so let me sort it off. You wanted to do like this, huh?
Just.
Okay. What will happen here if you do like this?
Just
It is creating a sorting always will
sorting
create
of
actually
this.
will create actually this one list, right?
Yeah.
Okay. So this doesn't work out actually. Okay. So moving on to the next important data type. Okay. See, so far we discussed these objects, guys, these data types actually. I've shown you the classification, right? At high level classification of the data types in Python. Okay, so far we discussed about the integer, complex number, float I've already discussed. Strings are already done, list is already done, tuple is already done. Okay, now we are discussing the next important one, that is set. And next important one is dictionary. Boolean we already discussed, right? Set and dictionary. With that, we can complete the data types concept. Okay, so dictionary also very, 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 very important one. Okay, if you understand the set, then dictionary will become easy for you. Set is similar to your list only. Everything is there again. Okay, so let's start. So you guys have to tell me the differences between the these data types. Okay. Now set is also a collection of objects, guys. When I say collection of objects, objects can be homogeneous or heterogeneous. Objects are elements, you can call it in any way. Okay, so objects can be, or elements can be homogeneous elements or heterogeneous elements. Similar kind of data types you can take, or different kinds of data types also you can take as a collection. Okay. And one more very important point is set is unordered. I've already discussed this point yesterday. While comparing the list, actually, list elements, I told you already, set of L1 equal to set of L2 I've taken. Why did I take that one? Because sets are unordered. Lists are ordered. That is the reason why it was not able to compare that elements. But sets are unordered. When I say unordered, so let me take you this example. 31452 I'm taking here. Okay. Same example I'm just trying to take here. See, while defining the set, actually, first element I've taken 3, second element 1, third element 4, 5, 2, right? When you try to print that one, I cannot give any guarantee my list will display the elements in the same order. You may or you may not get this in the same order. You may or may not. I cannot give any guarantee. That means, okay. See, I wanted to give some conclusion out of it. Just try to observe that. See here, what it is giving. Is it giving in the same order? Whatever the order I've given here, is it displaying in the same order?
No.
But in the case of set, in the case of list and tuple, is it giving in the same order?
Yes.
While I was creating that list object or tuple object, whatever the order I mentioned, the same order it used to display. But in the case of set, actually, it's not displaying in a proper. Next time, when I execute it again here, I cannot give any guarantee. Again, it will give in the same order. It may give in the different order also. You may or you may not get it. Okay.
So if we can convert this one to list or
Yeah, you
tuple,
can.
right?
Any point of time. Yeah. Any
So
point of time.
after converting, if we print, it will print the same like 31452, right?
See, we are not
convert.
understanding the behavior of the list, right? We are understanding the behavior of the set here. Of
Yeah.
course, if you don't want to change that position, or if you don't want to change the order, then you can convert happily at any point of time to list. I'm discussing about the behavior of the set.
Shiva,
Okay.
one more time you write print statement of my set.
But I cannot give you, don't
Yeah,
ask me why it is giving the same result. Okay. Okay. I cannot say anything for that. That depends, actually. See, since these are numbers, it is displaying the same order, but no guarantee. If you take like more elements, you may get in a different order. Okay. Okay. So this is first behavior, guys. First property of the set, actually. Sets are unordered. Set is a unordered collection of collection data type, I can say. Okay, and that is iterable, of course. In the for loop, we can use we can iterate every element in the for loop. And they are mutable. What do you mean by mutable here? Can we change the elements? Can we
Yes.
change the elements?
Yes.
Okay. Okay. So, tell me one thing here. Since the order is not fixed here, okay, can we access the elements using its index or its position? Can we?
I guess no.
No way. No way. My underscore set of, my bad, guys. Sorry. Set of, let's say 0 I'm taking here. What it will display here? What it is saying? Set object is not subscriptable. Because see, the order is not fixed, right? If you try to access the elements using its index value, which value it has to print here? Which value it has to print? So that is the reason why you cannot access the elements of the set using its index. Clear?
Okay.
Now, one more thing I'll tell you. Since indexing is not possible, can I go ahead and change this value 3 with 10? Can I go ahead and update? Can I go ahead and update my set of 0 equal to 10? I wanted to replace that 3 with 10 here.
No, right?
No, that is not possible, right?
Yeah, that's what. No.
First of all, indexing itself is not possible, right? See, indirectly, what you're trying to do, you're trying to access that element using its index value, and you're assigning some value to that one. See, item assignment is not possible. But Shiva, you said like it is mutable, right? How to modify that one? You can add the elements, but you cannot modify the existing elements. That's why I mentioned it is mutable. Clear? I'll tell you that add function bit later. See how I'm relating the each concept here. Try to understand that. Sets are unordered because the order is not fixed. Indexing is not possible. Since indexing is not possible, item assignment also not possible. All these are interrelated.
Slicing also not possible, right?
Of course.
Yeah.
Of course. Okay. 0:4 I'm taking here. Okay. So this 10 I'll try to remove. Execute this one. See what you're getting. Indexing is not possible means slicing is obviously not possible. Okay. Yeah. So now we made conclusion here, and moving on to the next one. Insertion order is not preserved, but elements can be ordered. Elements can be ordered, but insertion order is not preserved actually. Okay. So one unique behavior of the set is actually, okay. Let's say I'll just try to mention here 3, 4, comma 5 again I'm taking. So I'm just trying to, while defining the set actually, I'm just trying to take the duplicate elements here. 3 is repeating, 4 is repeating, 5 is also repeating here. Okay. So set does not allow duplicates. Set does not allow duplicates. Okay, see what is happening here. What it is printing actually. Okay, let me remove one print command. You'll get confusion. Why I'm printing twice. Okay, let me execute this one. What it is giving. While creating the set, I can mention actually. But while printing internally, what it is taking here. Is it taking the duplicate values also? Is it considering the duplicate values also? No,
No.
it doesn't. Okay, this is the unique behavior of the set actually. I'll tell you one use case that I've done this week in my project. Big set related to set. Once I get into the methods, I'll talk about that. Not now. We use these concepts actually in real time, guys. Don't think that okay, these are Python concepts. We don't need to understand all these things. They are important. Otherwise, why would I discuss? Why would I waste your time? Okay. Moving on. So not only homogeneous elements, guys, you can also have like heterogeneous elements also. That means here this is integer, this is float value, this is Boolean value. You can take any kind of data type here. So set method actually, our set function creates actually a set in the backend. So sets actually we need to represent within what I can say curly brackets. Curly brackets. Sets represent set we have to represent within curly brackets. Okay. Okay. Moving on to the next one. Of course, you can convert it any point of time. You can convert into a tuple or list. Any point of time you can convert it. Okay. Um, okay. Let's say one good interview question actually. People will ask you. So what they will give you, they'll give you L1 equal to. Okay. So 1 comma 2 comma 3 comma 1 comma 4 comma 5. This is what they'll give you. Okay. Hey, can you delete the duplicates from this list? That's what they mention. That's what the question they ask you. What is the best way to delete the duplicates from this? One is duplicated value right here. What is the best way to delete that duplicate? I wanted to have only unique elements in the list.
You can just convert
What
it
is
to
it?
set.
Simple, straightforward. If you know the subject, see how simple you're answering that. If you know the behavior of the set, like you're answering it easily. Simply convert that into set. That's it. You're done. Okay. Now L1 equal to, so what I'm doing is set of L1, right? Set of L1, right? Now, is it going to create a set or list again? Set, right? Now, on
Set.
top of this one, you try to use list here, list function here. That's it. Done. You're done. And print of L1 here. Print of L1. That's it. You're done. See, 1, 2, 3, 4, 5. How simple is this? Okay. This is really an intro question. Really. Okay. And next, so I told you, right? We can add the elements to the existing set. So for that, we have a function. We have a method called add. We don't have append. We don't have insert here. We have a method called add. We have add. Okay. So let me try to discuss about that. Copy this one and try to give it here. The method name is add. Okay, so S1 equal to 10, 20 apple I'm taking here. I just wanted to add one more element, 100 here. Now, where are we, where it is going to add this? Is it going to add at the end or is it going to add at the first place?
We
Come
don't
on.
know that.
We don't know that actually.
Yeah.
Anyway, sets are unadded, right?
Yeah.
What is your problem whether it is adding at the first position or the last position? Okay, it can put at any place, right? See here it is putting in a first place here. But there is no guarantee that every time it puts in a first place. There is no guarantee. Okay. Now, based on this particular method, can I say that sets are mutable? Sets are mutable. So if you want, I can print the existing address here. How can I print that one? So print of same thing. I'll try to print it here. Okay, before adding, after adding here. I'm just trying to print it. See, address is same. Since the address is same here, see, this is before adding the 100. This is after adding the address, 100. So address is changing here? No. Since address is not changing, so this behavior, we call it as immutability. Okay, similar to your list. But item assignment is not possible. Existing element we cannot modify because the indexing is not possible, right? Because of that, item assignment is not possible. Clear? Next, remove. So we have this method even in the list as well, right? We have this method, right, in list as well. If at all, if you want to remove the elements from the existing list, so we use actually remove method, right? But remove method takes the index value also, right? That's what we understood, right, in list. But since we don't have indexing concept here, can we remove the elements based on the index? You can pass the element directly here. So 10 I'm passing, that means it is going to delete actually object 10 or element 10 from this particular set. But can you delete the elements or objects based on their position, based on their index? No, not possible. Not possible. So it is deleting 10 directly. It is creating the new set. I mean, the same set. It is deleting in the same set.
So you mean address will be same, right?
Address will
When
be same,
deleting.
yes. Okay, let me print that one as well. Copy this. Before remove and after remove. Okay, let me execute this one. See, address is not changing. Because it's a mutability, mutable object, right?
Yeah.
It will not change. Okay, moving on. So we have one more like remove method is there indirectly. Okay, so one property or one behavior of the remove is if the value is unable to remove, we get key error. Okay, so what they are trying to say here is, let's say you're trying to remove 10, right? I wanted to remove 100 here. So do we have element 100 in this particular set? Do we have that? No, not there. So since it is not there, we are getting the key error. But we have one more method actually, that is discard. This also does the same operation. That means it removes the element or item from the set. But if the item does not exist or the element does not exist in the set, it doesn't throw any error. That is the difference between discard and the remove. Set object has no, okay, discard spelling is wrong. Sorry, CRD. I'm sorry, guys. My bad. CORD I wrote here. Okay. So see, is it removing the 100 here? Is it removing? Is it throwing any error? Since the 100 is not there in the set. So is it removing is it removing first of all? No, since the element is not there, it is not removing and it is not throwing error also. Okay. So that is what the difference between the discard and the remove. Both like does the same operation, guys. Both actually removes the element from the set, given set. Okay. And we have seen already clear, right? What clear does? What clear does?
Clear the remove
Clear
all
the
elements.
elements from the given object, right? Okay. Same thing only. Yesterday, whatever we understood, right? Same thing only. Okay. Nothing is changing here. So let me execute this one. So I have defined the set like this, 10, 20 apple. Length of S1 is currently 3 elements are there. So we are going to get 3 length. After clearing, actually, I just wanted to identify the length. Now C will get a 3 and 0. So print we need to use, right? Print of, sorry, print of length of S1. Okay, here also print of length of S1. See what you'll get here, 3 and 0. Okay, clear? Moving on to the next one, very important ones we need to discuss. So pop is also there, right? To delete the element actually, to remove the element. Okay, so in list actually, pop removes the last object, right? That's what we understood right yesterday. That's what we understood, right?
Yes,
What pop does actually?
it removes the last element.
Here, since we don't have indexing concept here, we cannot give any guarantee which element it is going to delete. Okay, so let me show you that one. So this time it is deleting actually 10 it got deleted. Now once again if I try to, okay, so pop I'll try to write it multiple times here. Print of S1. Okay, now see here. This time it deleted 20. Do not think that, okay, like it started deleting from the first position. No, don't think that. Don't think in that way. So it deletes the arbitrary random element actually. That's what I mentioned here. This function removes the arbitrarily a random element from the given set. Since you're getting the behavior like 10, 20 here, do not like come to a conclusion that, okay, it starts rating from the first position. No, it's not like that. Okay. Next one. So subset, superset, we've already we've seen this kind of concept in our childhood days actually in mathematics. Subset is nothing but let's say if I take two different sets here. Okay, let me explain that one. So if I have two sets here, set 1 10 20 30 40, set 2 10 40. If I say S2 is a subset of S1, that means all the elements in S2 are there in S1 or not. If they are there, then we'll get true. If they are not there, we'll get false. Let's say we have here 50 also. So what is the output of the first one? False. Because 10 40 is there and 50 is not there, right? That is the reason why you'll get a subset, superset. You guys know, right? I mean, I don't need to discuss that one, right? It's a general English meaning only. Okay, now let me execute this one. So first one we are getting true because all the elements in S2 are there in the S1 definitely. So 1040 it is there, 1040 it is there. So S1 is a subset of S2. So all the elements in S1 are there in S2. Are there in S2?
No.
No. So we are getting false here. So S1 is a subset of S1. All the elements are there in S1 are there in S1 only, right? So you'll get true here. So S2 subset S2 means you'll get true again. Empty set is a subset of S2. Empty set is nothing but no elements are there.
Yes.
You'll get true. Okay. So S2 is a subset of empty set. S2 means like we have 1040. 1040 elements are there in the empty set. Empty set is nothing but no elements. No elements. Is a subset of empty set. 1040 is a subset of empty set. No, you are getting false here. Clear? Okay, moving on. Even superset also same thing. Similar concept. So subset, superset, we can represent with this symbol as well. Less than or equal to also. I mean, see, we don't use these things too much. There are some other important methods are there. We will discuss that one. Those are important one actually. Okay. So is disjoint is also one of the method. What is the meaning of this one is? This function returns true provided both sets are having different elements. Completely different elements. If you have at least one common element, you'll get true. Sorry, false. If both sets are having completely different elements, completely different, then you'll get true. If they have at least one common element, you'll get false. At least. Okay, let me try to take one example here so that you'll understand. Copy this one and try to put it here. Okay. S1 I'm taking 10, 20, 30, 40. S2 Python data science I'm taking here. Okay. S3 10 true. One common element I've taken between S1 and S3. S4 I've taken Python and 25 here. S1 is disjoint of S2. True or false? Is disjoint means both are completely different elements or not. That's what it checks actually. Okay. So S1 is having actually 10, 20, 30, 40 is disjoint of S2. So elements are completely different or not? Are we going to get true or false?
True, sure.
True. So what about the second one? S1 is disjoint of S3.
False.
At least one common element. 10 is a common element, right? Between S1 and S3? Yes, we'll get false. So what about third one? S1 is disjoint of S4. Do we have any
False.
common elements?
True. No common.
No common elements, true. Okay. S2 is disjoint with S2. S2 only.
True.
True. obviously. Because, true.
Oh, sorry. Disjoint.
S2 only.
If it is same, right?
Same, right? Same means like false, right? At least one common
False.
element false, right?
Correct.
So false you'll get. What about the last one? S1 is disjoint with
Also,
false one. See, that's what we got here. Clear? I mean, we don't use this one. Don't worry. I mean, just since I have to discuss the concept, I'm discussing this. Okay. Next important method, sir. Union, intersection, and the difference. They are very, very important. What union does? Even this is similar to your SQL union only. What union does in SQL? I have one table that is employee 1. I have another table that is employee 2. Both are having same column, same data type. So when I say select star from employee 1, union with select star from employee 2, what you'll get?
Data will join from both tables.
Union. Or union all.
Yeah, it will
At least.
delete the duplicates between the two tables and it will print the remaining all, I mean, unique values from both tables.
Exactly. So same thing will happen here also. Okay, so let me try to take two different elements here. Now let me execute this. Okay, now what I wanted to do is S3 equal to like a dot union of B I'm taking here. This is the notation we need to take, guys. So set object dot union of B. Okay, so my set object is A. That on top of it, the method name is union B. Okay, so see, why I'm discussing this one multiple times, why I'm saying it is important means in PySpark also we use the notation as is. As is. Here we are talking sets. There we'll talk about the data frames. That's it. DF data frame dot union of data frame 2. Data frame 1 dot union of data frame 2. That's it. Syntax is also same. Concept is also same. Everything same. But there we'll try to understand with respect to SQL. That's it. Here, sets. Okay, now let me execute this one. See what happens here. Print of S3 we did not execute, right? So print of S3. Now see what you're getting here. 0, 1, 2, 3, 4, 5, 6. So 2 is a common element between these two, right? Now is it deleting the common elements? I mean, is it taking the unique values?
Yes.
Unique or not?
No.
Even in SQL also, union operation performs actually unique records or not? Union takes the record. Union takes the unique values or not? Unique records or not?
Yes.
Yes. Same behavior here also. Concept will not change.
Sure. These operations will perform only in with the sets, or we can do same with any list and as well.
No, only sets. Union concept is applicable only for sets. Not for the list, not for the tuple. As far as I know. Okay. If you want, you can try with the list as well.
Just change the curly brackets to.
Okay, yeah, I can go ahead and do that one for you. Okay. See, list object has no attribute union. If it is there, I could have discussed, right? Union method.
Yeah, just.
I'm pretty sure this is not applicable to list and this is not applicable to tuple. Okay, yeah, so good. Like moving on, this one. Now, a difference. What is the next method? Intersection, right? Okay, intersection I'm taking here. In place of union, INTERSECTION, intersection. A dot intersection of B. What you'll get? Intersection means
0, 2.
0, 2 are the
Common
common elements you'll get. That's what you need to say. Common elements you'll get. What are all the common elements are there between these two sets?
0,
0 and 2. So output I'm expecting the same, 0 and 2. Okay, that is about the intersection. We use this one also, guys, in real time. Union also we use, intersection also we use. I'll tell you the real time use case also once I discuss the difference. Okay, next method is actually difference. A minus B. Difference means minus. A minus B. So what does it do actually?
13135.
No, theoretically you tell me what does it do?
So what are the elements that are not in B?
Not in B. Okay. That means it removes the common elements. And
Common
what are all
elements?
the elements are there only in the A that it will try to display, correct?
Yes, yes.
Not common elements. Apart from common elements, what are all the extra elements are there in the A, it will display that. That's what are all the common elements we have here? 0 and 2 are the common elements. Now, is it going to give difference 1, 3, 5, 6, 4 or only 1, 3, 5, 6?
1356.
1, 3, 5, 6. It will not display 4. It will not consider the elements from the other set, second set. When I say A minus B, it will display elements only from A. Okay, now let me execute this one. See what you're getting? 1, 3, 5, 6. Okay, so I'll tell you the real-time use case that we have done this week. I have like a target column names and I have source column names. I was trying to compare both. Okay, I'm performing some validation between source and target. So for that, I'm just trying to validate actually target columns and source columns. Let's say in source we have employee number, employee name, salary, commission. Okay. In other table, in the target table, we have like employee number, salary, commission, department number. Okay, I just wanted to compare both columns are both tables are holding the same columns or not. Okay, so and I wanted to know actually what are all the extra columns are there in the source table? What are all the extra columns are there in the target table? Okay, let me tell you with an example so that you'll understand here. Okay, so let me take the same thing here. Okay, so but instead of A, source columns, I'll take here. Here I'll take TZT underscore columns. Okay, now tell me what are all the columns you know that you try to tell me here. Okay, EMP underscore number, comma, EMP underscore name. Okay, only 3 to 4 elements will take, not much. Okay, so comma, salary. Okay, single quotes we need to mention here. This is what we need to do. Okay, so in the target also we have same element, but extra one column is there. That is department number is also there. Consider, I'm just taking an example here. So DEPT underscore number. And here we have one more column. Let's consider job. Okay. Now I wanted to compare actually what are all the extra. Okay. So I just wanted to compare actually whether the column names are same or not in the source and target tables. Then how do we get it? How do we get it?
You can do minus, right?
Only A minus.
No, before that one, I just want to compare. See, with this one, you'll get the differential columns actually. But I wanted to compare actually before that one. If they are not same, then I wanted to display on top of it. If they are same, then I wanted to exit from there.
A general. Okay.
Oh. So I told you already yesterday.
Equals. Yeah.
Equal to we can take here. We can compare like this. Okay, if they are same, okay, if you want, you can write the if condition here. Okay, if they are same, then don't do anything. Okay, I'll just write here the real-time use case only. Okay, if source columns equal to target columns, then colon I wanted to print here, print both are same. I'm just trying to write it here. Both are same. Okay, so now if they're not same, then else condition I wanted to write it here. else I wanted to find out the difference. For that, actually, difference columns equal to or extra columns in source equal to extra columns in source equal to equal to source columns dot target columns. Okay, then what you'll get actually? What you'll get? Okay,
Yeah.
else we need to put it in this block like this, right? This is what I've done in my real-time program actually. Now what you'll get actually? If you
Yeah.
want to know what extra columns are there in the source as well, target as well, you can happily take that one also, right? So target equal to, okay. So here in place of source, we need to put target here. So sorry, Control Z, sorry. Copy and put it here. Okay. Now see what you're getting. We need to print right actually here. The other one also. Print, extra columns in source, extra columns in target also, we need to print it. Now tell me what you're getting here.
Department.
Is it not right?
If you do minus also, we'll get it, right?
That's what I've done, right? Minus. Difference is minus only, right?
Yeah, yeah.
That's what I've done here. Minus, see, you can do like this also. Instead of writing here, minus like this. That is also fine. I can do like this also, happily, no problem. Minus symbol is also allowed here. This is what you're telling, Bharat?
Yeah.
Yeah, same thing only. This is also like symbolic way we do like
Yeah.
this. That's it. That is the reason I'm telling you, all these are important. Okay, so intentionally what I will do is I'll just try to remove this job here and department number here. Now, like both are holding the same column names.
Yes.
Now what it will print here? Both are same. Okay, that's it. Very simple. See, known concept only we are trying to apply here. That's it. Nothing complex here. Of course, I did not explain if condition, else condition, but these are simple only, right?
Yes, sir.
Okay. That is about the difference. Symmetric difference is nothing but delta, guys. What I can say is it removes the common elements and it will try to display the elements from both the sets actually. That is what we call it as a symmetric difference, A delta B. Getting? It will display these elements and display common elements it will try to remove. It's a union of these two. Okay, if you want, I can do that one also. Symmetric difference. I don't want to type this one. I just wanted to copy paste. Now 1, 3, 5, 6, 2, 0. 0, 2, 4 are the elements in B. Now, if you want to see symmetric difference between A and B, now tell me what you'll get. Symmetric difference means common elements it will try to remove, and the elements from A, extra elements from A and the extra elements from B, both it will try to display. Now see what you'll get. 1, 3, 4, 5, 6. 4 also we are getting right here. 4 is actually from B. Clear? Symmetric difference update means it will try to update that elements directly in the source set. Source set means like if you're taking A dot symmetric difference update of B means like it will try to update that elements to this particular set. That's it. That is only the difference. Okay. So nothing to do with that one. So update is similar to extend. So we have seen the extend operation, right? Extend method, right? Yesterday. So here it is similar, but the difference between this one is here it will try to update the elements. I mean, it try to concatenate the elements directly to the source set. Source set means like on top of set one you're using, right? It will simply update that. Okay, let me try to show you that example so that you'll understand. We're almost about to complete this set concept, guys. Bear with me 10 more minutes. I'll finish it off. So set one, I'm taking 1, 2, 3. Set two, I'm taking 5, 6, 7. Okay, set one dot update of set two, and I wanted to print set one actually. So print of set one I'm taking here. I wanted to tell you the difference between these two. Okay, that's it. So before I write that update command, I'm just trying to print that one here. Now let me update here. See, let me execute this one. So before update method, it is printing the set values as is 1, 2, 3, and after update set 2 actually holding 5, 6, 7 here. It is simply concatenating those elements to this particular set, to the source set directly. That's it. Similar to extend. Clear? Copy, I've already told you right yesterday. Shallow copy concept is there. It is similar to that one. But anyway, I'll discuss this shallow copy and deep copy again, maybe in the next class. I did not get a chance to look into that one yesterday. I'll explain it again. Okay. The last one, frozen set. Frozen set is nothing but actually, I mean, we don't need to understand this one much, but try to understand once the frozen set. Okay. The functionality of the frozen set is similar to set, but an object of the frozen set belongs to immutable. Immutable, and the objects in both immutable item assignment, and I mean, you cannot go ahead and add any elements to the frozen set. That's it. Once you create that one, that is fixed. That's it. So we don't have any special symbol here. Frozen set of that object. That's it. You'll get like this. I mean, it's not that important, but just I'm giving you concept here. That's it. Oh, okay. Last concept. Methods. We already discussed add, clear, copy, difference update, all these things. Okay. I think functions are not there in the here. Functions are not there, I guess. Length of the set we can. So same like your this one, min, max, and the length is also applicable to set, guys. Same like other objects. Now come on, tell me. What is the difference between list, tuple, and set? If somebody asks that question, what is your answer?
List has square brackets and tuple has round brackets and set has curly brackets.
That is the first difference.
Yeah. And list is mutable, ordered and mutable.
Mutable, correct.
Tuple also same.
Tuple is mutable.
Sorry, immutable.
Immutable. Ordered but immutable.
Ordered and immutable.
Yeah. This one set.
And both set
unordered.
Ordered and
unordered,
mutable.
not ordered. Unordered.
Sorry. Unordered, mutable, and not allow duplicates.
Doesn't allow duplicates. Yes.
Duplicates.
Exactly. Okay. Yeah. So the next data type is dictionaries. I'll discuss this one in the next session. So we are done with the major ones.
Shiva, difference update. What is that?
Difference update. I told you, right? Like it will go and update actually directly to the source set. Source set directly.
Okay.
Okay. It doesn't create any new object in the backend. It will directly modify that source object. See here, that is what I'm trying to print here. Even if you try to print here, it will not display anything. See, result equal to A dot semantic difference at B. Then, so what generally people think that it will take the elements, it will concatenate and try to put that result in the result variable, right? But that will not happen. That will not happen. Okay, result is nothing. It doesn't create any object here.
Yeah, got it.
Okay. Yeah. So I'm done, guys, for today. Any questions so far?
So can we convert list to set?
Yeah. Why not? Why not? Yeah. So I think I did not discuss that one. I'll discuss that one also now. So L1 equal to, I'm just trying to take 1, 2, 3, 4, 5, 45, 100 I'm taking. Okay. So
Can you give duplicates as well?
yeah, okay. I can give that one. 4, 5 again I'm taking. Sorry, 4 we don't have, right? So 45 I'm taking again, and 3 again I'm taking here. Is that okay?
Yes.
Now, what do you want to convert here? Set.
Yes.
Okay. S1 equal to set of L1. That's it. Now, if you want to print that one, print of this S1 is nothing but unique values. 1, 2, 3, 100, 45. And if you take tuple here, okay, same concept. See, same output you're getting. I executed that. If you want, I can run this one more time. See, output you're getting same. List to tuple, tuple to list, set to tuple, set to list, anything. Vice versa, it is possible. One data type to another data type, we can convert easily using their using their functions. List, set, and tuple functions. Okay. Yeah. If no questions, you can wind up.